Hello, this is Dr. Gardner. We're going to be working a few extra samples with respect to mass percents. Let's consider a sample of limestone that we want to determine the mass percent of each element in. Let's say that we have a sample size that's 3.75 grams. It contains 1.80 grams of oxygen and 0.450 grams of carbon. In order to find our mass percents, remember we're looking at the mass of each element divided by the entire sample mass. Okay, so we're going to go ahead and take the mass of each element here, and we only know the mass of carbon and oxygen. So I can't find the mass percent of calcium yet, but if you remember, we could determine by mass difference the mass of calcium present. So we'll look at that in the next slide. Right now, let's find the mass percent of oxygen, and then we'll find the mass percent of carbon with the data given. So if I take 1.8 grams of oxygen, which is my mass of oxygen in the sample, and if I divide that by the entire sample size of 3.75 grams, that would give me a mass fraction at that point of oxygen, which is useful if I wanted to multiply that by any sample size of limestone to determine the number of grams of oxygen in that sample. So my mass fraction at this point would give me 0.480 for my mass fraction. And if I want to find a mass percent, I merely have to multiply by 100. And I'd find that the mass percent here for my oxygen would be equal to 48%. And to three significant figures, that's going to be 48.0%. Okay. If I want to find the mass percent of carbon, I'm going to use the same technique, except we had 0.450 grams of carbon in the limestone. So I'm going to go ahead and take 0.450 grams of carbon, divide that by the entire sample size of 3.75 grams. That gives me a mass fraction for carbon, which would be, in this case, 0.120 to three significant figures. Sorry, this is a 2. And if I want a mass percent, I merely multiply by 100. And we'd find the mass percent for carbon was 12% by mass. Now, if I add these two mass percents up, I don't get to 100% because I have not accounted for calcium's content. What I could find, though, is that the 48 and the 12% would add up to 60% of the mass total. And if there's only one element we haven't found the mass percent for, that being calcium, that must make up the rest of our percent. So if I have 100% total for the masses of all of my elements, and if I subtract the 60%, we would find that the mass percent for the last element, which is calcium here, would be 40%. So I can go ahead and use my understanding that all of my mass percents add up to 100 to determine that mass percent. So that should be 40.0% to three significant figures. Okay. Now I could have found this by another method. I could have also calculated my mass percent of calcium by determining the mass by difference. So I could take the 3.75 grams of my limestone sample, which has all three elements present in it, subtract the other element masses that I know. So I know that I have 1.80 grams of oxygen, and I have 0.450 grams of carbon. If I subtract those masses from the mass of the original sample, then the difference in mass must be the one element that we didn't identify by analyzing the sample. So that would give me a mass difference here that would be 1.50 grams. So I must have 1.50 grams of calcium in my sample. Now if I take the mass of the calcium, the 1.50 grams, divided by the mass of the entire sample of 3.75 grams, and multiply by 100, that will give me a mass percent calcium. And we'll see we get the exact same answer. We get a mass percent that is 40%. So to 3 significant figures, we get 40.0%. We also will notice that if we add that up to the percentage of the other elements, all the percent should add up to 100%. So this is the mass percent of calcium. Okay, so we saw two different ways now to determine a mass percent of an element whose mass wasn't given. Either we can find the mass percents of all the other elements and realize that that last percent must add up to the total of 100, or we can find the mass difference from the original sample. That missing mass must be the element that we didn't analyze for. So you can solve homework problems or exam problems via both methods. They both could be quite useful. Now let's apply what we know about mass percents a little bit here to some other types of problems. So let's say we are looking at lithium carbonate. Now lithium carbonate is used to treat certain types of mental illnesses such as bipolar disorder. But if we were told that lithium carbonate contains 18.8% mass by mass lithium, and we were told that a dose of the lithium was 1.20 grams, we could find out how much lithium is by mass with respect to that dosage. So we could take 1.20 grams of the lithium carbonate, here, and if I want to find out how much lithium is there in their grams, I need a mass fraction. So if I take my 18.8% of lithium by mass, if I divide that by 100, so if I divide that by 100, I'm going to find that I have 0.188 for my mass fraction. And if I multiply that mass fraction by the mass of the sample, whatever the sample size is, once I have that mass fraction, I can multiply it by the sample size. That will give me the gram content, in this case, of the element that we are looking at. So I multiply by the mass fraction of lithium of 0.188. That gives me a gram quantity here of 0.226. So I have 0.226 grams. That would be the grams of lithium present in a sample size of 1.20 grams of lithium carbonate. Now, I could have had a sample size that was much larger in grams or much smaller in grams, multiplied by that mass fraction would still give me the gram quantity of lithium present in the lithium carbonate sample. So we can use these mass fractions or mass percents to determine the gram quantity of any element in our samples as long as we were given the mass percent and the sample size. Now let's say we have a quartz sample of silicon dioxide. Silicon dioxide sample here we're told contains 46.7% by mass silicon. Now if I'm given that mass percent, we realize we can divide that mass percent by 100 to get a mass fraction. So if I divide that by 100, we can get a mass fraction that's equal to 0.467. That mass fraction of 0.467, I can go ahead and multiply that by any sample size to find out the grams of silicon in that sample. So I can take the 348 grams here of my quartz, multiply it by the mass fraction of silicon in the sample of 0.467, and I'm going to find that I would have in this sample 163 to 3 significant figures grams of silicon. Okay, so what we've seen so far is that we can use mass percents and mass fractions to determine the gram amounts in any sample size of an element that we're interested in. So you'll have to do a few problems like that on your homework, so make sure you keep practicing these. I hope these additional extra practice questions that I worked out for you will help you out on that homework assignment. Okay, have a great evening.